Hello. In this video, we're going to continue our study of logarithms. Now, log base 10 of 10 equals 1. That's easy. But what about log of 12? We know that this will be a little bit bigger than 1, but it's going to be some ugly decimal. And how we would figure it out, I guess we'd just use a calculator. But what if we were given log of 3 and log of 4? Like, suppose that we already had these numbers. Don't worry too much about where they come from right now, but suppose someone gave you log 3 as this gross decimal and log 4 as this gross decimal. Could you find a way to combine those to create log 12? Well, I'll give you a bit of a hint here. 12 is 3 times 4. What that means is log 12 would be the same as log of 3 times 4. But 3 times 4, we know that log rules go in two directions. If you have log of A plus log of B, that's log of A times B. This is taking the log and compressing it. You can compress it into a single log. But you could think about reading it the other direction. And you could think about expanding it. If you had two numbers multiplied, you could expand it into two logs. Well, let's do just that. Log 3 plus log 4. Now, log 3 we know is 0.477. And we know log 4 is 0.602. Now, all that's required is to stack these decimals and add them up. This is a little tricky if you don't remember how to add decimals. You have to put the decimal in line, and then you just add them like normal numbers. 2 plus 7 is 9. 7 plus 0 is 7. 6 plus 4 is 10. Carry the 1. And then you drop the decimal down in line with the other decimals. So we get 1.079. Now if you check on your calculator, log 12 is indeed 1.079, and then 181, and so on. But we're good to 3 decimal places. And we are able to come up with log 12 given these other two logs. Now, this is actually a thing. It's not a thing that we do anymore because we have calculators. But back in the day, people used to do this. They didn't have access to calculators. They had access to what were called log tables. And this is similar to when we were talking about trig tables. It's like, how do you find the trig value of all of these angles? Well, what you do is you look them up in a table. Someone has painstakingly calculated all of these by hand using, multiplication, division, some different algorithms, maybe some different shortcuts. But what they've done is they've compiled them all into a giant table, like into a big book. And then you use the numbers in that book to come up with your own answers to your own questions. So before calculators were invented, log tables like this were often in the back of textbooks because students would need to know log of 3 and they wouldn't have access to a calculator, so they would be given it as 0.477, and they'd need to log of 4, which is 0.602. And the thing is, you couldn't make a log table to include every number because, once you get into the hundreds or the thousands, this log table would just be too big. It would be just like this giant book full of logarithms. So you make a smaller table, and then you use some logic to use that table on larger numbers. It's kind of cool, kind of clever. So how could you use this table to approximate the value for log 42? Now, there's different ways to write 42 as multiplication. 42 is 21 times 2. But that's not going to be great because we do have 2 in our log table right there, but we don't have a 21. We can write 42 as 6 times 7, and that seems like a better move because the 6 and the 7 are both in the log table. So we need to rewrite the 42 as numbers we have access to. So now we can write log 42, which is log 6 times 7. Use our log rule to write it as log 6 plus log 7. Hit up the 6 as 0.778. Hit up the 7 as 0.845. And then we combine those values. Again, I'll show you one more example. After this, just do the addition on your own. But we'll do one more just to make sure you're good here. 5 and 8 is going to add to 13. Carry the 1. 7 plus 1 is 8, plus 4 is 12, carry the 1. 8 and 8 is 16, carry the 1, and then we drop the decimal down in line. So the answer is 1.623. All right, so let's go ahead and determine these questions without a calculator. We'll go to 3 decimal places, and I'll put the log table here so you have it as a handy reference. Go ahead and find log of 180, log of 64 over 3, log of the square root of 196 over 2 to the 10. So go ahead and give those a try. All right, so for the first one here, we need to write it in terms of numbers on the table. Let's think about this as maybe log, well, I guess I could do 180 as 18 times 10, but I don't have an 18 on the table, so I probably need to go even further. This would be 2 times 9 times 10. Yeah, I see those numbers. So this would be log 2 plus log 9 plus log 10. And then the number 2 is right here. The number 9 is right here. And of course, the number 10, well, I mean, that's just a 1. So we add up all 3 of those values, and we get 2.255. All right, let's try the next one. Log of 64 over 3. 64 is 8 times 8. And so I'll write this as log of 8 times 8 divided by 3. Now the division, we can split it up as log 8 plus log 8 minus log 3. So we notice the 8's up here, the 3's over here. So that's going to give us 0.903 plus 0.903 minus 0.477. So that should give you 1.329. All right, square root of 196. Whew. And then 2 to the power of 10. Now, hopefully you know the square root of 196. That's going to be 14. So that's going to help us a little bit if we simplify it. So we could write this as log 14 over 2 to the 10, which we could write as log 2 times 7 over 2 to the 10. And now this is where it gets a little tricky. We'll write log 2 plus log 7 minus log 2 to the 10. But the 2 to the 10 is not a number on the table. Log 2 is on the table, not 2 to the 10. So we take that 10 and we move it down. Let me just continue this over here. So we'll have log 2 plus log 7 minus 10 log 2. So what that means is we have to find the number for log 2, which is right here, and then we multiply it by 10. So it becomes 3.01. So here you have 0.301 plus 0.845 minus 3.01. You can put a 0 at the end if you want. And then we go ahead and calculate all of those numbers, and we see what we get. So that should give you negative 1.864. All right, I got one real tough one for you here. I'll make sure you can still see the log table. But we have log of 52,920 divided by 2 to the power of 3 times 3 to the power of 3. So you're going to definitely need to take that big number and break it up. Try to find a way to write it as smaller numbers multiplied, maybe make a factor tree. But go ahead and pause the video and give that a try. All right, assuming you gave this a try, let's go ahead and take this 52920. First off, I'll divide it by 10. So that's going to give me 10 times 5292. Then I can break the 5292. I could divide it by 2. So that's going to give me 2646. Could divide it by 2 again. It's going to give me 1323. Now I know it's going to divide by 3, so that's going to be 441. Divide by 3 again. 147. Divide by 3 again. Oh, I'm getting a little running out of space here. Divide by 3 again. 49. And that's going to be 7 and 7. The 10, of course, is 2 and 5. So when we rewrite this, we have log of I've got 1, 2, 3, 3 2's. So 2 to the 3. I've got 1, 2, 3 3's. So that's 3 to the 3. I've got a 5. And I've got 2 7's. Now, this was very intentional on my part. We can go ahead and cross off these, so that's nice. And we're just left with log 5 times 7 squared, which we can write as log 5 plus 2 log 7. The multiplication becomes addition, and the power pops down. Now, just looking up here, if we scroll up just a bit, we've got the 5 right there as 0.699. We've got the 7 right there as 2 times 0.845. Now, unfortunately, that means you have to multiply some decimals, but hopefully you remember how that works. And then you have to add the 0.699. And this should give you 2.389. Now, just for fun, I'm going to go ahead on my calculator and type in the original question. I'm curious to see how close my approximation is. I think it's pretty good, but I would like to just see just for my own peace of mind. Now, when I type this in on a calculator, I get 2.3891. So good to 3 decimal places. And I feel pretty cool being able to calculate a log like that. Such a big log, in fact, by only using the numbers 1 to 10 in a log table, and of course, using the skills of expanding and rewriting the numbers. So this is a short lesson here. This is mostly on approximating logarithms. It's not really its own topic. It's more just like a nice application of the log rules. We have calculators today, so we don't usually do this anymore. But it shows up every once in a while on a test or an exam as like a little application question. So let's go ahead here and say, I guess if you had the number maybe 30, we could break this number down as 5 times 6, which we could even break down further as 2 and 3. So this is called prime factorization. And it helps us because then if we're going to do log 30, which is a large number, it's a little easier to do log of 2 times 3 times 5, because then I can just look at log of 2, and then log of 3, and then log of 5. And these values usually come from a table. They're usually given from a table. So as an example here, why don't you find log of 800 divided by 1024? And to do this, I'm going to give you 2 values. I'm going to say you're given log of 5, and you're going to be given log of 2. So log of 5 is 0.699. Log of 2 is 0.301. So I'll give you those 2 values, and you got to figure out the rest. All right, hopefully you gave that a try. If we take the 800, we should break it up as 8 and 100, which is 10 and 10. So 2, 5, 2, 5. And the 8 is just 3 2's. Now the 1024, that's actually just going to be a bunch of 2's, like so many 2's. If you count by 2's, it's going to be 2 to the power of 10. So you just break it up into like 10 2's. So then we get log of, looks like 1, 2, 3, 4, 5 2's and 2 5's divided by 2 to the 10. So if you want, you could actually simplify this as log 5 to the 2 over 2 to the 5. It's got some nice symmetry there. And then we write this as log of 5, but there's a 2 in front, minus 5 log of 2. Now we go ahead and type in our numbers here. So 2 times 0.699 minus 5 times 0.301. 1. Just in case you're struggling, I'll show a quick log multiplication here. 0.301 times 5. 5 times 1 is 5. 5 times 0 is 0. 5 times 3 is 15. And 5 times 0 again is 0. Add that 1. And then here, because the second number has no decimals, if you notice there's 3 decimal places. So you move it over 1, 2, 3 decimal places. So you get 1.505. Over here, you should be getting 1.398. Subtract the two numbers, and that gives you negative 0.107. And if you're so inclined, you can check it on a calculator, and we're good to go. Now, if you want some further practice, you can look at Unit 9, Worksheet number 4. And then you can write down any things to remember. Again, I really like that rule for the exponents. I think it's really crucial to remember that if you have log of 2 to the 5, that's the same thing as 5 log 2. The fact that you can take that exponent right here and you can kind of hop it down is really useful for questions like this. All right, hopefully you enjoyed this video, and as always, thanks for watching.